Hello, beautiful people. Ready to get started? Okay. Before we do, though, I want to draw your attention to the board. Okay. It's very important that you look at the board right now. Beautiful. Notice how there's a new deadline for your project. Because I love you so much, and because I'm just worried you're not going to have enough time in class, since you have to use the compasses in class to do your project. I've just pushed it back. There's no rush. It's fine. So the new deadline will be April the 6th, which is next Friday. So we'll have time in class today after you take these notes. Possibly some time next class. The class after that is a review day, so you'll definitely have time then. Excuse me, then. And then April 6th it will be due. Same day as your celebration of learning. How exciting. Same day as the end of the cycle. All right, got all that down. And you can also read through the board for your instructions today. You're going to take these notes. I have 2 videos because it wouldn't let me do it all in one. And after that, you're going to work on your project. All the supplies are going to be over on the bookshelf. I have compasses, rulers. I have the copy paper out for you to use. And Ms. Pate should have the class sets, either the instructions or the list of designs. It's also on my website. Cool? Make sure before you leave, you put back any supplies. Do not leave this room a mess. You hear me? Okay. I love you. Okay. Before we get started, also, if you look on the bookcase, there's a yellow box. That has geometric templates, which just, it's like, what are they called? Like stencils. So when you're doing today's lesson, right now, if you want to use the stencils to draw hexagons and pentagons and so on, feel free to borrow that. Just put it back before you leave. Okay, today we're talking about regular polygons in 9-2. First, we want to define a regular polygon. Regular means that all the sides are congruent. A polygon, that just means it's a closed figure with edges. So 3 or more sides. So we can have any one of these. Okay? Obviously, you start with 3 sides is a triangle, 4 sides is a quadrilateral. And if you know all these, you don't have to write them down, but I'm listing them here in case you don't know them. 5 sides is called a pentagon, 6 sides is called a hexagon, 7 is called a heptagon. That one's kind of unique. Octagon is 8 sides, 9 is nonagon, 10 is decagon, 11 is undecagon, 12 is dodecagon. And that's pretty much all you need to know. If I were to continue, like let's say I had 32 sides, guess what that's called? A 32gon. Yep, that's all we say. No, it's weird. So like n-gon, where n is your number of sides. Yeah. Whoop, nope, there it goes. Number of sides. Okay. Also, I have to apologize in advance for all my sniffling and my coughing and this ridiculous voice that I have right now. I sound like a frog or something. It's these allergies. They're killing me. Okay. Oh my gosh, you know what we didn't do? Obviously. Yay math? Did you do it? Did you say yay math? Yay math! Okay, good. So, let's start with the pentagon. You can use your little template if you want to, but we have to define some important things. I'm going to move this up. Alright, so 5 sides, doesn't matter, who cares. What we want to define is the segment from center to a vertex. That is the radius, radius of the polygon, which seems kind of weird. I thought that was only for circles. Silly Miss Coffee. But it's not. It's for all shapes. So if you imagine that there's a circle like this, ooh, that was bad, but pretend like it goes through all the vertices, the radius of that circle intersects, it goes from the center to the vertex of the polygon. So that's a radius. Just in case you need to know that. You do need to know that. But what you really need to know is this right here. So if I go straight down, forming a 90-degree angle, that is what we call an apothem. So yes, that's fun. Like say a possum, but with a little bit of a lisp. Apothem. Apothem. Get it? It's a legit mathematical term. I did not make it up. What it is it is the segment from the center of a polygon, a regular polygon, so they have to have congruent sides, perpendicular to the side. That is the apothem. So why on earth do we need that? We need that to find the area of a polygon. So the area of a regular polygon, so it could be anything, pentagon, hexagon, decagon, is going to be apothem times perimeter divided by 2. Apothem. So A is the apothem. Maybe you should write this out to the side somewhere. P is perimeter of the whole polygon. A is the apothem. That's it. Okay? So you just need to know that. AP over 2. Apothem times perimeter over 2. Just memorize it. Okay? Great. Let's do an example. Okay. Find the area of a nonagon with the apothem equal to 21.98 centimeters and the side equal to 16 centimeters. So you could draw it if you wanted to, even though it's a nonagon, it's going to be really hard. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, not bad. So each one of those has a side length of 16. All of them are 16. Because it's a regular one, even though I didn't say that. I should have said that. My bad. Find the area of a regular nonagon. There we go. So the apothem goes from here straight down. So it's here, here, 90 degrees. That is 21.98. Okay. So to get the area, here's our formula. AP over 2. You haven't memorized yet? You should. AP over 2. So the apothem, that's 21.98. But what is the perimeter? Perimeter is when I add up all the sides. But they're all the same, right? So if they're all the same, 16, all I have to do is multiply by the number of sides, which is 9. Right? So 9 is the number of sides. A lot of times I'll call that n. n equals 9. So we do that. Right? 16 times 9 is 144. My apothem is 21.98, so it's just a matter of plugging it in. Area is 21.98 times 144. Divide that by 2, and you get some number that I will tell you right now. There we go. Area is 1582.56 centimeters squared. And that's all you gotta do. Just plug it in. Okay? Cool. Next. Find the area of a pentagon. So pentagon means it has how many sides? 5. Okay, so we can draw it or not. We don't really need to draw it. We just need the formula, which we already memorized. AP over 2. Good job. We know the apothem is 13.76. What's the perimeter? That's what else? That's the other thing I need. You're going to do the side length, that's 20, multiplied by the number of sides, that's 5, which is 100. So AP over 2 is going to be 13.76 times 100 over 2, which is 688 units. I didn't give you units. Units squared. How easy is that? This is great. This is going to be a great lesson. I feel it already. Alright, so let's do a little different now. Find the perimeter if the apothem is 15 and the area is 246 meters squared. So my formula is AP over 2, AP over 2, AP over 2. Got it? So let's just plug it in. A, as in area A, sorry. So capital A is area, is 246. The lowercase a is the apothem, so that's 15. The perimeter, I don't know. P. Divide by 2. And solve. Do you remember how to solve for this? You should. Multiply both sides by 2. So 246 times 2. That's going to be 492 equals 15 times P. Divide both sides by 15. So the perimeter is 32.8 meters. Now, did I tell you what kind of shape this was? No. Does it matter? No. We're done. We solved it. Happy days. But if I did give you the shape, let's say this were a heptagon, find the length of the side. So heptagon means it has 7 sides. And if my perimeter is 32.8, all I need to do is perimeter 32.8, sorry, and divide by how many sides there are, so 7, and that will give me the length of each side. So that's approximately 4.7 meters. So that is the length of each side. So that's just a second part to that example. All right? Okay, so this next part, last part, I promise. Okay, now yes, it's going to get a little harder. Okay, most of your homework problems are what I just did. Very easy. You might have one problem like this one, so I want to do it with you so you know how to do it. It's finding the area of a hexagon with the side length of 4, meaning you don't have the apothem, so you have to first find the apothem. Then you can use your formula to plug in. Okay, ready to try that? Oh, hold on. I'm going to have to cut it off and go to the next video.